Now I introduce path integral guided policy search. We have introduced how to use the pi-square to improve the local policy for a model-free system. Now we use the pi-square as a local policy optimizer to help search for the optimal policy to control a robot. Suppose a local policy is a time-varying linear Gaussian controller, P, which can be expressed as a Gaussian distribution. Here we use the pi-square to learn the forward control vector and the covariance C. To do so, we use the local policy on the robot system to generate samples. Then we calculate the cost to go loss S on the trajectory, each trajectory. Then we use this S to calculate the probability. From here, we can see if loss is small, that means that a sample have a higher probability to be or close or to be the true trajectory. Here, the eta, this temperature factor. We can handle it as hyperparameters or solve it in a dual space. At each step, this local policy can be used as the target policy to train the global policy. So we can sample, by using the local policy or use this global policy on the real robot to generate samples. So then finally we got the guided policy search problem is defined as this minimum problem subject to the constraint, which makes sure when we make this trajectory loss small enough, make sure the global policy is the same as the local policy. Allow them have what small difference. So the minimum problem subject to the constraint can be converted to Lagrange. Here we can select this different theta for this problem, or we can solve it by using the alternating direction method of multipliers in a dual space, solve this mu, and finally we got the solution. Based on this result, we can design a neural network, deep neural network, to extract the useful feature point from observation and send this output to a policy network to generate the policy to control the robot. The state here include two parts. One is the observation, is a raw image from the camera, onboard camera. And another part is the inner state, is a raw robot state. So to make sure this deep neural network can extract the useful or correct feature points from the input image, we design this output. This is called a pre-training output. Make sure this CNN can correctly extract the features from the input image. Here, the skip connection just help to increase the resolution or just help detect the smaller object. And we got this feature point together with the inner state as an input to the to the policy network. Here, the first image, that means when the robot arm moves, it may block some object. So if the intruding object is blocked during the robot arm moving, so we should recognize it when it appears in the observation. So we use the first image to make sure when block the image is appear in the observation, we can recognize it. So here, this is the policy network for the input. We generate the policy to control a robot. For more details, please check with this reference. And thank you. Bye.